Hey there, and welcome back to a new lesson of the C# for Total Noobs training. This one will go one step further once again, and we'll talk about a very interesting topic that we'll probably cover during the next couple of parts and or sessions. And this is the topic of collections. And this topic is kind of like a little bit related with arrays. Actually, all the lessons that we had recently are related to arrays in some way, because first we talked about arrays, then about multi-dimensional arrays, and then about strings, which are nothing else than an array of characters or chars. So right now we go one step further and we talk about something that kind of like have a lot of the concepts that we have encountered for the arrays, but that are more flexible, and these are collections. And there are different types of collections. We will actually discuss them one by one. The most common that we will probably use in virtually any application that you build is the list. And then here you see on this title is list of t. We'll go into what is t actually means, and we'll see also, of course, in practice. But before we get on going with the coding part, let's have a very brief understanding about what collections are. So when we talked about arrays, we told or we said that they are actually a way of grouping objects of the same type. Now, collections are actually the same thing. So collections provide us a way to group objects of the same type, I would add, although this is not really clear here, and I will briefly also say, or in a few moments, I will also explain why. But collections provide a more flexible ways to work with group of objects, because it actually, or the collections usually allow us to dynamically grow and shrink the group of objects. So what does this actually mean? We said that when we talked about arrays, one very important thing about the array is that it has a fixed size. You cannot simply add elements to an array that actually are over the capacity of the array that you have declared at the beginning. And you cannot, of course, also remove elements from the array. Uh, but with collections, things are totally different. In collections, we don't have to provide a fixed size for them, so they can grow dynamically. If we add something, then the collection will get bigger. If we remove something, then the collection will actually shrink. So it's very dynamic for us to work with. And there are some collections that are a little bit more specific, where we can even store group of objects, let's say, in form of key and value pairs. And we will see some scenarios in which this type of collections or grouping objects based on keys could prove to be very important. Now, I said that usually collections are also or contain elements or objects of the same type. Now, in collections, things can be also a little bit different, because theoretically you could have collections that are not strongly typed. So you can have a list in which you don't specify exactly what type of objects will contain that list. But to be honest, this is not something that we currently do when we write code. So whenever we work with collections in C# and .NET, we always use all of, let's say, the so-called generic collections, which also provide an exact type for the objects that will be part of that collection. Now, as we saw in the first videos when we talked about Visual Studio and the structure of our projects, we have also talked about namespaces at a certain point, and there is a namespace which is called System Collections Generic that actually contain all the collections that we can use in C# and .NET, but only the generic version of them. So the version in which you can specify exactly what type of objects you want to add in that collection. So the advantage of this is, of course, that whenever you retrieve an element from a generic collection, you do not have to determine its data type or convert it to a different data type, because you have a very high predictability. You know that whenever you retrieve an element from a collection, it would be always of the declared type. Now, when we go to the coding part, we'll exactly look into also how or what actually this idea of generic means. Now, Before we go into the coding part and enter the first type of collection that we will walk through, and that will be the list, I just want to briefly show you four types of collections. Of course, in C# there are several other types, but these are the types that you would actually encounter more often than the others. And we have the dictionary of T key and T value. We'll look into exactly what this means when we'll talk about a dictionary. And this is the type of collection in which I said that we can store objects, but we can actually store them as key and value pairs. So for each object, we would have also an appropriate key. And of course, the keys need to be unique, but we'll look into that deeper when we talk about dictionaries. Then we have the really most common collection type that you will use on a day-by-day basis. So you will, I guess, every day, if you start working as developer, there will be no day in which you won't work with a list. So the list is a very simple representation of a group of objects that can be, of course, accessed by index, and it provides us methods or behavior or functionality to sort, search, and modify the list. So this is one other very nice thing about lists and collections in general, that they usually also provide methods for sorting, for ordering, and things like that, which on arrays actually don't happen by default. Okay, then we have queues and stacks, which are two very common data types in programming. So the concept of queue and the concept of stack are virtually exactly the same in all programming languages. And even though you won't use queues and stack that often in your day-to-day code writing, these are, as said, very important data types. And as a developer, even if you are at the early stages of your career, you have to be aware of what a queue is, what are the characteristics of a queue, what a stack is, what are the characteristics of a stack, and so on. And then there is also the sorted list of T key and T value, which represents also something like a dictionary. And we'll see exactly what a dictionary is when we'll talk about the dictionary. But the only thing here is that this list is actually sorted. And this is very important because in this case, you can know the exact order basically of the elements that are part of that specific sorted list of T key and T value. And yeah, that's actually mostly it. Now, before we go to the code, I just want to go here. Let's look at the list, because this is the first collection that we will actually look into. And we have here this idea of list of T, and you see here this T in angle brackets. So what is this T? Whenever you see something like a T in angle brackets, or it could be also other type of notations like T key and T value, as we see for the dictionary. But whenever you see this type of notation in C#, it means that we talk about a generic class. What does this actually mean? It means that we have, when we define the class, in case of the list, we don't have to, because Microsoft has already written this class for us, but we need to know how to consume it. But the idea is that when you create or when you define the class, you define also a placeholder for a data type. And this T is nothing else than a placeholder for a data type that you would have to provide once you declare and or instantiate the list. So this means that whenever we want to create a list, we will have to say list of int, or list of string, or list of double, or list of my class, and things like that. So whenever we want to create a new list, we have to also declare in angle brackets the data type. So this is what we need to do as developers when we use this class list. If we would write our own generic class and we want to make it generic, then we would have also, when we write the class, when we define the name of the class, to also specify in angle brackets the T. So it would be my class of T. This is how we read it. Once again, this T is actually a placeholder for a data type that we have to provide when we declare and instantiate that certain list in this case, or generally speaking, when we declare and instantiate an object of a generic class. But about generic classes, we'll talk a little bit more at a certain point. For now, we just want to focus on this concept of collections, and in this case, the concept of list. So let's go over to Visual Studio right now and start actually working with a list. But in this case, we'll do this a little bit different than we usually did the demos, and we'll create here in the same project a class for each type of collection demo that we want to go through. So I say I want a class, and I will call this class list demo because we want to demonstrate this. Let's make this class public, and in this class there's actually nothing very fancy. We'll just provide a static method, public static. It could also be void, and here run demo. Okay, and here is actually all the code that we will write. So for in other lessons, we have written everything here in static void main, and we executed the program. Let me just also make this runnable. But in this case, we just have this list demo with this method, and we'll put all the console write lines and the code that we want to run here. And instead, in this program.cs file, we'll just say here list demo dot run demo, and that's it. Good. Now, of course, when this happens, everything that we place here will be executed, and this means that all our console write lines and read lines and things like that will get executed, so we will be able to see outputs on the console, and also, if necessary, read inputs from the console. Now, let's get started and working with lists. And here the first part is, let's see how we can declare and instantiate lists. So this is the first thing that we want to look into. And there are different ways that we can do this. So the first way that we look into is something that I guess we have already used for regular objects. And in this case, they are called collection initializers. What does this actually mean? It means that when we declare the collection and we instantiate it, we already provide also the elements in that collection. And this would be, for instance, let's create a list of string. And here, just remember what we said just a little bit earlier. When we want to use this list, as we want to use the generic list, which is the list of t. So when they have created list, let's press F12. We see that it is list of t. So when Microsoft has written this class, it has declared this t, which means that it is a placeholder. So it means that whenever we want to create a list, we need to provide here a data type that will define the elements or the type of the elements that will be contained in this list. And this is called generics. So let's call this cities, and let's add here a list of cities. Now in this case, we instantiate a list just like a regular class, because list and all the collections are regular classes. And what is the collection initializers? As said, we can use a collection initializer when we know exactly the data that we want to put into a collection right when we start it. So we can just put these brackets here, these curly braces, and here, for instance, we can provide, let's provide cities. So one of my favorite cities, Seattle. Then one of my other favorite cities is Munich. And one other city that I really enjoy very much is Lisbon. Although I visited Lisbon only once, but I really enjoyed it. And of course, we need a semicolon here. So this whole part, the fact that we use these curly brackets right after we have created a new instance, like with new list of string, and that we have provided the values, this actually means that we have used a collection initializer. Now, for instance, there is a second way to do this. If we want, for instance, to defer the adding of elements for a later time, we can simply use just a simple object creation, because a list in the end, from a perspective of what classes are, is nothing else than a class. So we can have here another list of string, and let's call it names this time, and we just say it's new list of string, and that would be it. So now we have created the object. So after this line executes, we have already a functioning object. it will be of course empty because there is no element in the list in comparison to the first way that we did it. So with the collection initializer, in this case the list is already populated with 3 elements. In this case we just create a list, but the list will be empty. Now what we can do is, let's for instance add elements or add new elements in the list. Here for instance, let's also say adding elements to the list of t. Okay, so what we can do right now, for instance, and here is where the big difference comes when we compare these two arrays. Collections, and this means lists also, are dynamic. So you are really not, or you don't have to obey or follow the consequences of a fixed size enumeration of objects. In this case, the size is dynamic, so you can, at whatever time you want, add a new element to the list. And once again, at whatever time you want, you can remove elements from the list. So it's just simple or as simple as that. In code, this is once again very, very simple. When we click on names, we have here the add method. So of course, add method, if we hover the mouse over it, adds an object to the end of the list of t. So in this case, names is a list of string, which means that we would have to provide a string. And well, let's provide here, for instance, my name. But to see why we actually use generics is that we said here that we want a list to be of data type string. So this means that all the elements in this list need to be a string. If I, for instance, try to add a number, we get an error here. And here, well, the error is not exactly, or maybe it's not very intuitive, at least if you are at the beginning, but it says that our argument 1 cannot convert from type int to string. What this actually means is that this method right now expects that our argument should be a string, and I have provided an integer here. So this is why we cannot even compile this code right now. So this is the power of having a type-safe programming language and using generics and be always sure about the data types of the elements in a collection. So let's get back and add a string. Now for the cities, for instance, we can do also cities.add. So once again, it's no matter that we have already added here 3 values. At whatever time we want, we can come back and say, hey, I want to add something else here. In this case, I want to add Mishwara, which is actually the city that I am currently living in. Now, okay, the idea here is very, very simple. This is how we can add different elements. And now, because there are some very, or there is a lot of code that needs to be written here. I will just copy paste and then go through what each line of code actually does, because it doesn't really make sense to really type everything. It will take a long time and it's not justifiable. But if you're watching this training or this session, then please feel free to pause this video and type and write everything by your hand. As said, it is very important, and I cannot emphasize enough how important it is that you write code by your own hand, because this is how you get actually accustomed about syntax and code writing and how Visual Studio behaves, and even shortcuts and things like that. So this is once again very, very, very important. Just use or stop the video, type everything, and then go on with the video. So now let's go back here and just talk about what we try to achieve here, because we are doing a lot of console write lines that want to underline the different functionalities that we have on a list and that we don't have, for instance, on an array. Now, on collections, when it comes to counting the elements, because we also can do this when it comes to collections, and of course, when we talk about a list, in this case, the property is not called length anymore, but it's called count. So here, what we do here is we just count how many cities do we have right now in this list. Then a collection, as said, as it is a group of objects and a list. From this perspective, it is similar to the array, but this also means that you can access each element also by its index. So in this case, we say that the second element in the list is, and we use here cities and provide here 1, because as the array, also collections or indexes of collections are also 0 based, so they start from 0. So this means that the last index of a collection will always be the collection count minus 1, exactly like it was the case for the array. So this means that when we try to access the element on the position 1 or on index 1, we try to access the second element, which in this case should be this one. So this is one way that you can access one element of the list. But then you can, or you have also the possibility to remove an element from the list. In this case, we just want to remove an element from the list by specifying the index on which we want to remove the element. So in this case, we want to remove the city on the index 1. So it would be also this second city in the collection. And then we will see, and we write this same line again, and we will see that in this case, after we have removed an element at position 1, everything has actually shifted one index back. So it means that in this case, on index 1, we will have Lisbon, because Munich has gone away, and then Lisbon will be on the second place. And this means it will be on the first, on the index value 1. Now, of course, we can also insert at a certain index, and here would mean that we would insert on the index 1 the same city here that we added previously. In collections, we can have also elements that are, let's say, fairly equal, I would say. And then the index of the city, and we see the cities, this is the list, and we have here the index of. And we want to get the index of this city right now. And then what other thing that we do and that we cannot directly do on arrays, we can sort. So we have on list, on the class list of T, we have here a sort method that's kind of will sort our elements based on how sorting should be done for this specific data type. So if we want to sort strings, it will be alphabetically in ascending order. If we want to store integers, then it would be in ascending order once again, and things like that. So this will the sort do. Now for arrays, we would have to write our own methods to sort an array and then return the sorted array. But for lists, we can simply just use what we already have in the language. So in this case, we go then with a for each loop through each city in the cities list, and we of course write the city name. And then we have another method on the list, which is reverse, which actually will reverse everything. So it will reverse all the elements in the list. And then what we do is we loop once again through the list, and then we print once again all the cities, and we'll see that those are in reversed order. So let's maybe put here also a breakpoint, and let's run this application and go through all these lines one by one, and then follow exactly what happens in the console and try to explain why that actually happens. So first of all, of course, we hit our breakpoint, which is cool, and for now we don't have anything in the console to look at. So let's run, or let's go one step further. So once again, here we just want to say how many elements do we have in this list, and we use the count property for that. If we hover the mouse on it while we are debugging and we are actually in this breakpoint, we can also see that for here it indicates that we have 4 elements in the list, because 3 were added while initializing the list with a collection initializer, but another one was added a little bit later here. So in this case, when we execute this line, it should print in the console the number 4. So in this case, current number of cities in the list is 4, which is correct and expected. Now, what we do here when we execute this other line. So here, once again, we want to find out which city or what value actually is on the index 1. And this is how we do this. We can use an indexer just like we did for the arrays to access the value on index 1. So let's execute it, and I would expect it to be Munich. So I'm not sure exactly what happened here, because the execution of this program just or my Visual Studio is not responding anymore. Okay, because I have selected something in the console and it was blocked for writing. So, but if we open it once again right now, we see that the second city in the list is Munich, which is correct. But then we say cities remove at. So what this means is, once again, is hey collection or hey list here, please remove the element that resides on index 1. Now we know from the previous line that on index 1 we have the city Munich. So in this case, when we execute this line of code, this city should be removed. And while debugging, if we hover the mouse over the list, we can see that right now the list has only 3 elements. And if we go in it, we see that it's only Seattle, Lisbon, and Timisoara. So there is no Munich anymore. It means it was removed. Now, to make sure that this really happened, we also print this in the console. And here we see that in this case, the second city in the list right now is Lisbon and not Munich anymore, because Munich was removed and all the others were actually shifted one index position back. So basically, when you remove elements from the list, there won't be any blank spaces. So everything will be shifted so that we have a continuous enumeration of elements, and so that on each index we also have a value. Now here once again we insert a new city, and usually when we insert, this happens actually at the end of the list. And once, here we say that we want to insert a city at position 1 or at the index 1. So what this means is that at position 1, so between here city and Seattle and Lisbon, we will insert also the value Timisoara. This means that all the others will be shifted one index value forward. So if we place our mouse over cities, we see that this already happened. So we have here Seattle, then Timisoara, then Lisbon, and then once again Timisoara, which is very, very okay. So this really happened. We also write it in the console, and yeah, this is the index of Timisoara is 1, which is correct. And now we have this other method, which is sort. Now here in this sort, and let's put a breakpoint here, because it really it really doesn't make sense to go through each iteration of this loop. But we can see that after the sort, if we hover the mouse on this, we see that right now this is sorted alphabetically. So the first one is Lisbon, then it is Seattle, and then the two Timisoara values, which should also be equal. So if we just hit continue in this case, we will see that this was also printed in the console. So Lisbon, Seattle, Timisoara, and Timisoara, which is correct. And then what we do exactly the same thing, we just reverse. So in this case, let's also put a breakpoint here on this line. So we reverse the list. So if we go to this line of code, and if we hover the mouse on cities, then we see that it is right now reversed, because right now we start with Timisoara, then Seattle, and then Lisbon. And then of course we have here this for each that will print everything in the console. So right now, if we look in the console, we can see that yeah, we okay, so I guess we have to put a breakpoint, sorry, one step further and continue once again. And right now, when we look in the console, once again, we have printed the list. And if we compare these two entries, we see that they are completely reversed. So exactly what we should expect. Now, let's close this application for now. Now we don't need these breakpoints. Before we stop, I want to show you also something else, because when it comes to insert here, there are actually different ways to add the elements to the list, and we have actually looked into two. And whenever you want to add an element and you are not worried, or you don't really care on what index that element should be added, Then we have the add method, and that would simply add that element at the end of the list. Now, if you want to insert an element at a certain position, then you would have to use this insert. And here you have to specify the position, so on which index you want to insert, and then to specify the value or the object that you actually want to insert. So once again, just remember, if you want to add elements to a list, you have these two options. If you don't care about the index, then you can simply use add, and the element will be added at the end of the list. And then you have here cities insert if you want to insert at a specific index. Now, for removing, we have or we saw here that we have this remove at index. So this is when we wanted to remove an element that is on a certain index. But if we once again don't know exactly the index of the element that we want to remove, but we know the element that we want to remove. In this case, we have 2 times this element, which is called Timisoara. So let's just remove it. So in this case, we can just simply say cities dot remove, and here we can just simply say that we want to remove this one. And yeah, let's run this application again. And when we print all the cities in reverse order, then Timisoara should come up only once and not twice as it was before. So indeed, one of the entries was removed. Now, what actually happens here when we have this remove and we specify the value? If we have 2 elements with the same value, like it was the case here right now in our scenario, it will actually remove the first element that it finds. So it really will remove the element that we added first here. So this one, which would have been, I guess, on index 1 because it was reversed right now. So once again, the remove removes all or removes the first the first occurrence of the element that we specify here. Now, as we have probably observed, there is also a remove at, sorry, the remove all, which will actually clear the entire list. So if we what's the problem here? No, not remove at, sorry, let me just go here once again, cities dot remove all. Okay, and then we have here to specify, okay, we can specify here a predicate. That's a little bit more complicated. We will talk about actions and what and delegates and what could be a predicate. But here we can remove actually all, and we have we can specify a condition. And well, in this case, we don't know exactly what condition to specify, but the idea is that well, we have also an option to remove all the elements that that match a certain criteria. And if we want to clear the list totally, then we have a method which is called clear, and the clear method will clear the entire list. So it will remove all the elements, and we will end up with an empty list, just like we had here with names. This is what clear does. So once again, remove, and we specify an element that we want to remove. We have then remove at, where we specify an index and we remove the element on the specific index. We have then remove all, and we can specify a condition, and then all elements that meet the specific condition will be removed. And then we have clear, which will actually clear the entire list, so no element will remain in that specific list. So in this case, if we run the application now, we will see that basically the last line will not print anything because here the list is empty. So we don't have any elements in the list anymore. Yeah, so just remember these different ways of adding, yeah, then there's different way on removing, then we can also clear, and then we have the different functionalities that are very specific to collections, like the count and like the fact that we can access elements by their index and find out the index of a certain element, and things like that. And that pretty much sums it up. So lists are really not very complicated to understand, because it's also something that that is very natural and easy for us to actually visualize, because it's actually a list and we all do all kinds of lists all the time. So in this case, I guess that that would make it. And yeah, that's it for the concept of list. So yeah, thank you very much for watching this lesson, and I can't wait for the next one, and I hope to see you there. But until then, I really wish you the best, and good luck.